This section is this session is being brought to you by the Fractal Odd Dyadic Horizon. I came up with one fairly recently. Somebody has a very noisy microphone, whatever. Okay, for today, we will be solving trigonometric equations. Now, this actually was on last time I showed you the extra credits, and there was an extra credit said about inverse trig, and this was one of the sections in it. Somebody is making a very noisy microphone. Please silence it. Thank you. Yeah, like that. Yeah. So we'd like to solve the equation sine x equals a, cosine x equals a, and tangent x equals a. And seriously, somebody's making a great deal of noise here, and please silence your mic. All right, let's start off with sine x. Here's the graph of the sine function, a wave. And here's the graph of y equals a, and as you can see, it meets at two pairs of a pair of points, and these pairs march off by period 2 pi. So here it'd be x equals arc sine of, and then this would be arc sine of a plus 2 pi, arc sine of a plus 4 pi, and so on. So that one family of solutions is x equals arc sine of a plus 2 pi n some whole number. There's this, however, solution, which is sort of back arc sine a from here pi. So there the solution is pi minus arc sine a. And then that plus 2 pi n. The graph to solve cosine x equals a. Here's a graph of the cosine. Here's a graph of y equals a. And here would be the solution arc cosine a. Okay, I'm sorry, this is not working. Somebody's making a great deal of noise, and please stop it. I'm stopping share to see just who is on. Katie Worrell, please turn off your mic. Thank you. Sorry about that, folks. Let's proceed. Okay, so here's arc cosine a for x, and then you add multiples of 2 pi here and here and so on. Here's minus arc cosine of a, and then into that we add multiples of 2 pi. So arc cosine a plus 2 pi n minus arc cosine a plus 2 pi n. Now, to solve tan x equals a, we have all the graph of the tangent function. We have a graph of y equals a, and here is a solution x equals arc tan a, but tangent has a period pi, not 2 pi. So to arc tan a, you also add pi times n. So these are the solutions. So for example, solve for x between 0 and 2 pi, so in the unit interval, in the unit circle. 2 sine x plus 1 equals 0. Okay, first solve 2 sine x equals -1, sine x equals -1/2. Now, here we'll use a drawing of the unit circle to help us solve this problem. Sine is how far up and down you are. So let's go down to -1/2, draw a horizontal line at height -1/2, and see where it meets the unit circle. And again, this is the interval from 0 to 2 pi, so it has to be this angle or this angle. This is a breakback angle. This is a Pac-Man. Now, all right, it's down a unit 1/2, and here we have the 30, 60, 90 triangle. One side is 1/2, diagonal is 1, the other side is 3/2. This is in the third quadrant, so we're down a bit, down 1/2. This is 30 degrees. This is 60 degrees, or pi/3, and that's this is 3 pi/2 radians, and you go minus pi/3 or plus pi/3. So theta is 3 halves pi, this 270-degree angle, or plus or minus pi/3, plus or minus the 60 degrees. This comes out to 7 pi/6 or 11 pi/6. Are the solutions in the unit circle. Now, of course, since sine is periodic, we could also add plus 2 pi n to both of these, but here they're asking specifically in the unit circle. Here, 4 secant x plus 6 equals -2. Solve on the unit circle from 0 to 2 pi radians. Okay, well, first we subtract 6. 4 secant x equals -8. Then divide by 4. Secant theta equals -8/2 or -2. Then take reciprocals. Cosine theta is -1/2. Cosine refers to how far left or right you are in the unit circle. So we go back 1/2, draw this horizontal, this vertical line at x equals -1/2. And where does it meet the unit circle? Here and here. Here is an obtuse angle. Here's a breakback angle. Now, okay, as before, we're getting a 30, 60, 90 triangle. So this is pi over 3 radians here and also here. So we're going to have a straight angle, pi radians like this, plus or minus pi over 3rd. So that comes out. So pi plus or minus pi over 3rd. So the solution is 2 pi over 3 or 4 pi over 3. Those are the solutions in the unit circle. Now, again, you can add multiples of 2 pi, integer multiples of 2 pi for the general solution. 4 cos squared equals 1. Solve on the unit circle. Okay, divide by 4. Cos squared equals 1/4. Take a square root, and now cosine theta is plus or minus that. You have to take care about this quadratic ambiguity. All right, so vertical line at x equals -1/2, or vertical line at x equals +1/2. Again, we have 30, 60, 90 triangle, 60 degrees here, and here, and here, and here. So pi over 3 here, or straight angle minus pi over 3, so pi minus pi over 3, or straight angle plus pi over 3, pi plus pi over 3, or one full rotation minus pi over 3, that's 2 pi minus pi over 3. So the solutions are pi thirds, or pi minus pi thirds, or pi plus pi thirds, or 2 pi minus pi thirds. That comes out to theta is pi over 3, or 2 pi over 3, or 4 pi over 3, or 5 pi over 3. Now here it is 2 sine squared theta minus 1 equals 0. Solve on unit circle. Okay, transpose the 1, 2 sine squared equals 1, divide by 2. Sine squared theta is 1/2. So sine is plus or minus 1 over root 2. So you go up or down 1 over root 2. Okay, so that means we get a 1 over root 2, 1 over root 2, 1 triangle. These here and here and here and here are 45-degree angles, pi over 4. So we have this, which is at pi over 4, or this, which is at pi minus pi over 4, or this, which is at pi plus pi over 4, or this, which is 2 pi minus pi over 4. So pi over 4, pi minus pi over 4, pi plus pi over 4, 2 pi minus pi over 4. That comes out to pi fourths, or 3 pi fourths, or 5 pi fourths, or 7 pi fourths. Now here we have solution on the unit circle and solution, the general solution for all theta. Solve cosine 2 theta is -1/2. Now this 2 theta makes things a little more complicated. You'll actually want to get the general solution for 2 theta and then divide by 2. Okay, cosine 2 theta is -1/2. And so 2 theta is plus or minus, we had before, our cosine of -1/2 plus some integer multiple of 2 pi. Now, our cosine of -1/2, that's 2 pi over 3 here. And so 2 theta is plus or minus 2 pi over 3 plus 2 pi n. Okay, now we divide by 2 and get theta equals plus or minus pi over 3 plus pi n. That's the general solution for all theta. And by substitution, you find that the solutions in the unit circle are pi over 3, or 2 pi over 3, or 4 pi over 3, or 5 pi over 3 in the unit circle. So in this case, you want to find the general solution, which you may recall involves something like this, plus or minus arc cosine A plus 2 pi n. But because it was talking about 2 theta, we have to divide by 2 and get this general solution here and these specific solutions here. Now here we have 2 sine squared theta minus sine theta minus 1 equals 0. This is a quadratic and a trig equation. So okay, first we take this and we factor by previous algebra, elementary algebra methods, to 2 sine theta plus 1 times sine theta minus 1 equals 0. So either 2 sine theta plus 1 is 0 or sine theta minus 1 is 0. If 2 sine theta plus 1 is 0, then sine theta is minus a half. If sine theta minus 1 is 0, then sine theta equals plus 1. So here we go down 1/2 of a unit, or up to 1 unit, draw the horizontal line at these vertical heights. And what are the angles? Well, here is just one solution, pi over 2, 90 degrees. Here we have a 30, 60, 90 triangle. So here we're going to have 180, or pi radians plus pi over 6. That's 7 pi over 6. Here we have 1 full rotation, 2 pi radians minus pi over 6. That's 11 pi over 6. So these are the solutions. Pi halves are 7 pi over 6 or 11 pi over 6. And these are the solutions.